Hey everybody, it's Mr. White here with some notes for AP Macro and K-Level Economics from Unit 1. This is all about production possibility frontiers, also known as production possibility curves. So before we move forward, there's just a couple of important terms that you need to be familiar with. The first term is factors of production. That should sound pretty familiar to you guys by now. In case you don't know them, you can remember them with the acronym CEL: capital, entrepreneurship, land, and labor. Basically, those are the resources we need to produce things in the economy. Trade-offs, that simply just means this or that, like the options you have available. Anytime we make a decision, we have trade-offs. You could spend more time studying, or you could spend more time playing video games. Those are your trade-offs for this afternoon, right? So that's what trade-offs means. Now, opportunity cost. This is going to be the most important term on the list. It means the value of the next best option that is sacrificed when you obtain something. And one way that I like to remember this, I would say just sort of a great way that you can remember this, is with the term opportunity cost is opportunity lost. So I would emphasize that in your notes. You can highlight it like I've done right here. Now, efficiency means that all of our resources are being used in the best way possible. Okay, that's really key right here. Best way possible. Well, that's kind of a fat marker, huh? Okay, well, anyways, so no missed opportunities in production. So efficiency just means that you're not wasting any resources. Inefficiency is the opposite of that. That means when all of the economy's factors of production are not being used, okay, not being used in the best way possible. So there are missed opportunities in production. And this last term here, ceteris paribus. Don't get freaked out. You don't need to know how to speak Latin in this class, but just know that it's a term that we use in economics that just means all of the things held constant or all things held equal. In other words, it's just a simplifying assumption because there are so many factors in the real world that can change the outcome in a market. And so we just say ceteris paribus. In other words, like we're just going to focus on the variables we know about, and we're going to pretend like no other variables change. Okay, so first let's talk about the idea of opportunity cost, because it's really critical, okay? Understand that every decision requires you to sacrifice something else, okay? And this is all because of that idea of scarcity, okay? Scarcity, remember, is the idea that everything is limited. All resources are finite. So in economics, we often think that the true cost of something is what you must give up to get it. It's what you have to sacrifice. So in other words, things don't just cost the amount of money that you spend on them. They also cost the other things that you could have potentially spent that money on. In other words, if you get a lottery ticket and you win $50,000, and let's say that you go and spend that $50,000 on a brand new Corvette. Well, the opportunity cost of getting that Corvette is not just the $50,000 you had to spend to get the Corvette, it's also the missed opportunity to invest that money and potentially have more money down the road. So if you add the value that you could have earned by investing that money, plus the value of the Corvette, that's the opportunity cost of buying the Corvette. So another great example, and I don't want you guys to think I'm trying to talk you out of going to college here, but the cost of a college education. Most people, when they think of the cost of a college education, what do they think of? Tuition, books, room and board, buying a sweater with the name of the college on the front, right? All those kind of costs. But guys, there's one big cost a lot of people don't think about, and that's lost wages, okay? Now you might be saying, oh, but Mr. White, if I don't go to college, I can't get a good job anyways. That may be true, but even with a not so great job, let's say if you're just earning minimum wage, $7.25 an hour, if you work 40 hours a week, right? That means that if you multiply times 1 minus 0.1, that'll tell you how much your after-tax income is. Multiply that times 50, we're going to assume that you have 2 weeks off every year. You're sacrificing after tax $13,050 per year. That's what you could have in your pocket if you were working full-time, right, 40 hours, as opposed to going to school full-time. Now, let's say you go to school for 4 years, you multiply the lost $13,050 times 4, and that means that you're actually sacrificing around $52,200 if you were working a minimum wage job to go to college. So in addition to your tuition and your room and board and your books and all that kind of stuff, you also want to make sure you add in your lost wages. And so that could actually maybe tip the scales on whether you want to go to college or not, because perhaps the opportunity cost, if you have a good job already, is too great and you don't want to sacrifice that. Just think of like a great college athlete who ends up dropping out of college before they finish. Well, part of the reason why is the opportunity cost of lost wages. If you are somebody like, for example, De'Aaron Fox, and you have a chance to go professional in the NBA after only 1 year of playing college basketball, the opportunity cost of staying in college is way too great. And so you're just going to go ahead and drop out and go pro. Now, in more practical ways, we can measure opportunity cost with a graph, okay? And don't let graphs and models freak you out. This is the first graph or model that we're going to study in this class, and it's called the production possibilities curve. Now, it's not as scary as it might sound. It's just a way for us to visualize opportunity costs, but it can also help us visualize economic growth and efficiency, okay? And so that's why we use a production possibilities curve. As a matter of fact, don't get hung up on making it perfect, because these are just hypothetical. They create a simplified economy that produces only two goods and services. Now, there's no economy in the world that only produces two goods and services, but that's not the point. Even though the graph is really simple, it just helps improve our understanding of the idea of trade-offs and opportunity costs, because if you can understand the trade-off and opportunity cost between producing two goods, you can understand the trade-off and opportunity cost of producing any number of goods. The logic is the same. So this is it. This is the big scary graph, the production possibilities curve. We have two different goods. Like you can see on my y-axis, I've got capital goods, and on the x-axis, I've got consumer goods. Capital goods just means tools. Consumer goods just means stuff like t-shirts or Xboxes. Okay. Now you'll notice that on this graph, we have different points, like point A and point B and C and D, and they're all over the place here. But we also have this blue line. Now the blue line is the production possibility frontier, or the production possibilities curve, whatever makes you happy, okay? Now you want to pay attention to the location of these points, okay? Any point that's located on the line is considered feasible and efficient in production. In other words, point A and point B are levels of production we could actually do, right? Like we can produce YA level of capital goods, and we could produce XA level of consumer goods at the same time. And if we do that, we're using all of our resources without any resources going to waste. So point A is efficient. Alternately, we could produce level YB of capital goods and level XB of consumer goods, and we'd be at point B on the production possibilities frontier. Since it's touching the curve, it means it's efficient and feasible in production. So just in case you didn't know, guys, the word feasible just means realistic or possible. Okay. Now, you'll also notice a few other points on here, like for example, point C. Okay. Now, point C is to the left of our production possibilities curve. That means that it's considered feasible, so it's possible to produce at this level. I could just mark it out here. Okay. Like we could produce, let's call this YC and XC of this good. But the problem is that we're not utilizing all of our resources, because you'll notice that point C does not touch the production possibility frontier. Since point C does not actually touch the production possibilities frontier, that's why we would say it's inefficient. It doesn't necessarily mean it's bad. We're not really making a good or bad judgment. We're just saying that if we produce at level YC and XC, we're wasting resources. Okay, take it however you want. Now, the last one here, you'll notice point D is floating out there all in outer space by itself. Point D, or any point to the outside of the production possibilities curve, is considered unattainable for now, which just simply means that we don't have enough resources, based on current technology or just based on, resources available to produce at level YD or at level XD. Okay, you'll see that level XD is about the same level as XB, and so you might say, well, why can't we produce there? Well, because we can't produce this amount of capital goods at the same time. We just don't have enough land, labor, capital, or entrepreneurship to make that happen right now. Now, does that mean that we can never, ever produce at point D? No, of course not. Eventually, we could produce at point D. It's just going to take more resources or more technology, or potentially even trade with another country that has more resources or more technology. Now, opportunity cost, as we said, is what you have to give up when you make a decision, right? So the go-to is opportunity cost is opportunity lost. Okay. If you can remember that saying, you're good to go on opportunity cost. Now, we can calculate the opportunity cost of different combinations of production using one of these production possibilities frontiers, okay? The way we do that is first we're going to identify 2 points on the production possibility frontier to represent 2 different combinations of production. Next, we're going to identify when we move from one point to the next, which axis, the x-axis or the y-axis, decreases in value, okay? Now, the last thing we want to do is just find the difference between the 2 points on the axis that decreased, whether it was the x or the y. So we take the starting point minus the finishing point, and that tells us the opportunity cost. Okay, now if that was confusing, let's check out an example on the next slide. So let's say we've got an economy that produces clothing down here on our x-axis and wheat over here on the y-axis, okay? Now, we can produce any combination that touches this production possibilities frontier. Think of that as like the boundary of our resources. I'm going to put FOP for resources, okay? Remember that FOP means factories of production. That's why we sometimes call this a production possibilities frontier. You know, the frontier means like the boundary or the edge. So this is, you know, just think of like we can produce anything that's in this area that I'm kind of scribbling in, right? Anything here, any combination here, we can do like 2,000 and 2,000, that's feasible. We can do 1,500 and 3,500, right? That's feasible. Anything that's inside here, any combination at all, we can actually do it. Okay, now whether or not we want to do it just comes down to whether it's efficient or not. Remember, we should be going for efficiency because that's ultimately what's going to be our best use of our scarce resources. Okay, so if we were to change the quantity of wheat and the quantity of clothing, there's going to be an opportunity cost. So the quantity of wheat B decreased from point A to point B. Okay, so you'll see that we started off here at point A, we were doing, let's say, about like 3,200 bushels of wheat and about 1,500 garments of clothing, okay? But when we go from point A to point B, well, now we're producing, looks like 3,000 bushels of wheat and about 2,500 garments of clothing. Okay. So what we're doing first is we're going to look for which one got smaller. And so we can see here that it was wheat that got smaller. Okay, well, by how much did it get smaller? 3,250 was the starting point, 3,000 was the ending point. 3,250 minus 3,000, and that will tell us our opportunity cost. So the opportunity cost of moving from point A to point B is 250 bushels of wheat because 3,250 minus 3,000 is 250. And we always express opportunity cost in terms of the thing that got smaller. So the thing that got smaller here was wheat, and so that's why we say the opportunity cost is 250 bushels of wheat. Okay, now we can illustrate the opportunity cost of moving from luxury cars to compact cars on Toyota's production possibilities frontier. If you want to go ahead and read this, you can pause the video right here and read it. But if you get the point, then let's move on. All right, now these curves are not static. They can actually move around. And there are 2 different things that can cause a shift in our production possibilities frontier. The first one is a change in the factors of production, especially capital, okay? So if we're ever trying to move our production possibilities frontier outward to the right, that shows the economy growing. That's a good thing. And getting more tools and machines makes that process a little bit faster. Now, since technology usually applies to those tools and machines, that's why a change in technology can also increase our production possibilities. In other words, if we've got better ways of producing things, it becomes possible to produce more things with the same amount of resources, okay? Now, the production possibility frontier tends to move outward to the right, which is, like I said, an indication of economic growth, Okay, so if you've ever heard people talk about the economy growing, just remember that the economy is a system for meeting our needs and wants. And so if we're able to meet more needs and more wants with the same amount of resources, well, that means the economy has grown. So there you go, mystery solved. That's what economic growth means. If we get better factors of production or technology, right, the economy can all of a sudden produce more stuff and more people can have more stuff and we live better lives and we're all happy. That's why everybody likes economic growth. So another way that we could move this curve, in addition to just getting better technology or better resources in our own nation, is that we could take advantage of other countries' resources through trade. When we trade with other countries, we can, find places that have cheaper factors of production than our domestic factors of production, and that lowers the opportunity cost. That would be, that lower than what it could be possible without trade. Okay. Now, this is what it looks like when we shift the curve. If this is like our starting point, I'm going to put like number 1 right here. This is our starting point. You can see that point N is unattainable. But if we get more resources or if we trade with another country, all of a sudden we could be at graph number 2 here, where you can see that our production possibilities have increased. In other words, that boundary of what we could produce, it used to be right here. We could produce anything that's in this red area, right? But now that red area has increased to include, I'm going to do an orange one, okay, to include this orange area. So we've added all this extra production. In other words, we can produce more, and now point N that used to be unattainable is all of a sudden now efficient. Now, you may notice that these graphs have bow shapes, and that's because of increasing opportunity cost. Now, the reason that our bow-shaped curve is that way is because in reality, opportunity costs are typically increasing, meaning that as we shift production away from one good and towards another good, the cost gets bigger and bigger and bigger as we produce more and more, okay? If the opportunity costs were constant, the slope of our curve would be a straight line. Now, why is this the case? Well, as I said, when an economy produces only a small amount of one good, the opportunity cost is really low. Okay, so in other words, if we're only making a small amount of pizza, then the amount of food resources we need to make pizza is pretty small. And so the opportunity cost of making an additional pizza is also very small, right? We're not sacrificing much. Now, the reason why this is true is because we're only using resources that are well suited to the product that we're trying to produce. So if we're only making a small amount of pizza, then all the resources we're using are good for making pizza, right? Like the dough we're using is dough that's perfect for pizza. The cheese that we're using is top grade mozzarella. We're using special marinara sauce and pepperonis and all the things you would expect on a pizza. But as we produce more and more pizzas, if we start getting really crazy about pizzas in our economy, all of a sudden we're going to have to start using resources that are not well suited to the production of pizza. Like maybe we'll run out of the good crust and we'll have to use, like, I don't know, crackers or something. So we'll have cracker crust for our pizzas. Some of you might like that, but whatever. I don't think that sounds very good. Maybe we'll run out of mozzarella cheese and now we have to use goat cheese or something like that. And perhaps we'll run out of marinara sauce and instead we're going to have to use, I don't know, eggplant sauce or something like that. And so we could continue making pizzas, but the value of those pizzas, the quality of those pizzas is going to decline as we produce more and more. And at the same time, we're going to sacrifice other products for which those things that we're using now to produce pizzas would have been better suited. Like the crackers would have been better for going with our soup, so we're sacrificing more soup. The goat cheese would have probably been better with our Greek salad, so we're sacrificing more Greek salads as we produce more pizza. And that the eggplant sauce, I don't really know what eggplants are good for other than inappropriate emojis, but anyways, we're going to leave that for another discussion. All right, so let's take a look at this in practice, okay? If the other example with pizza doesn't make sense, let's think of it this way. If an economy grows a small amount of corn, it can be grown in places where the soil and the climate are particularly well suited to growing corn, but not well suited to growing other crops like wheat, okay? This means the economy only has to give up a small amount of potential wheat production to grow corn. So every little bit of corn we add is only costing us a tiny amount of wheat. So that means the opportunity cost is low. But as the quantity of corn grows in the economy, more land that's not well suited to corn and better suited to wheat production is going to have to be used for corn production. the result is that the additional corn production is going to mean sacrificing significantly more of our wheat production. In other words, at some point we might not have any more wheat and all we've got is corn. And that's a big cost because the corn's not going to be great quality. It's being grown in a place that's not good for corn. And at the same time, we have zero wheat. So we've gone from having sandwiches and some corn chips to having corn chips only because now we have no wheat. This is what it looks like on a graph. Okay, let's say if we start off, let's start at an extreme point. Let's start right here at the point that I'm drawing where we have 0 acres of corn. So at this point we have no corn at all, but we're getting 30 acres of wheat. So we've got lots of bread, we've got no corn tortilla chips. Maybe we decide we want some corn tortilla chips, so we're going to plant 20 acres of corn. So corn is going to increase from 0 to 20. Now, to do that, if we want to stay efficient, we're going to have to give up some of our wheat production. The only way we can produce more of one good is by producing less of something else. So we're going to have to give up some of that land that's being used for wheat in order to get more corn. But you'll notice that the first 20 acres of corn only costs us 5 acres of wheat. So going all the way over here on our x-axis only costs us that much on our y-axis. Let's say it's a pretty good trade-off. Now, if we start loving corn and we decide, hey, let's make more corn, maybe we want to do another 20 acres of corn. Well, how much wheat are we going to have to sacrifice to get another 20 acres of corn? Well, you can probably see already the next 20 acres of corn is going to cost us 25 acres of wheat. So what that means is that the second 20 acres was 5 times as expensive as the first. That's increasing opportunity cost. Now, the last thing we'll talk about here is constant opportunity cost. In many cases, especially for consumers with fixed budgets, opportunity cost is constant, and it can be traced out with a straight line. Like I said, if opportunity cost is constant, the production possibility frontier would have a straight line. So let's think of a real life example. If you've got a fixed budget to spend on food and gas each week, which, hey, who doesn't, right? You can actually trace out a consumption production possibility frontier to show all the possible consumption possibilities you face. Let's say that your favorite place to eat is Whataburger and you drive a truck, so you got to buy gas pretty frequently. Well, if you're trying to allocate your $60, your scarce resources, your money, between these two possible production or consumption, in this case, possibilities, we could trace that out. So if your weekly budget is $60, and let's say that your favorite meal at Whataburger costs $8. Maybe that's not realistic for you, but let's just roll with it. And let's say that a gallon of gas is $1.50, and who knows when you're watching this. Right now, a gallon of gas is about $1.50, so we're just going to assume a gallon of gas is $1.50. That may or may not be realistic at the time you're watching this, but let's roll with it, okay? Let's say that if you wanted to spend all your money on Whataburger meals, now you could do that, right? You could eat at Whataburger, let's say like 7 times a week off $60. And so here we would say that, this is Whataburger and this is gas. So you're going to get a lot of gas from Whataburger, but you're not going to get a lot of gas, if you know what I'm saying. You're not going to have any gas for your vehicle. And so here we go. That would be one potential efficient use of your $60. Okay. Keep in mind, you could also save your $60. Another possibility is you could spend all your money on gas, right? You might gas up your truck twice for $40 or something like, sorry, not for $40. You could get 40 gallons of gas for $60. And so you would maybe that fill your whole tank for the week, okay? And there's other possible consumption possibilities in between, right? Like maybe you could eat at Whataburger 6 times and buy 8 gallons of gas. Or you could eat at Whataburger 3 times and get 24 gallons of gas. Or you could eat at Whataburger just 1 time and you could get 34.67 gallons of gas. And so as you can see here, if you spend all your money, any of these possibilities are realistic for you. They're feasible. And you could also do any possibility that would be in this green shaded area that I'm doing right here. All right. So in other words, like you could also eat at Whataburger 2 times and buy 15 gallons of gas, and that would be a point like right here. Or you could eat at Whataburger 4 times and get 15 gallons of gas. And that's feasible, but it's inefficient. Now you can't do something like eat at Whataburger 5 times and get 25 gallons of gas, because that would be out here, that would be unattainable. Okay, so we're at the end of the notes. Here's the key insights. In other words, this is the basic stuff you need to be taking away from this lecture today. First of all, opportunity cost is the value of the next best option you sacrifice when you make a decision. Every decision we make has an opportunity cost, no matter how big or small. You're always going to have to give up something to get something. And the neat way to remember that is to say, opportunity cost is opportunity lost. So just, put that in your mental bank there. The next key insight is that we can measure opportunity costs on a production possibilities frontier, aka a production possibilities curve. Okay, any point that's on the line is efficient, any point that's below the line is inefficient, and any point above the line is unattainable, at least for right now. And the final key insight: the shape of the curve tells us if the opportunity costs for these two products are increasing or constant. If it has a bow shape, that means that it has increasing opportunity cost. And if the curve is linear, it means it has constant opportunity cost. That's it for today, guys. Thanks for watching the video. See you next time.